Hello and welcome. Today I'm doing trigonometry. First, we're going to start with defining the trigonometric ratios. To define a trigonometric ratio, you need to be working with right-angled triangles. All right-angled triangles have a 90-degree sine. 90 degrees and 90 degrees. Any triangle that does not have a 90-degree sine is not a right-angled triangle. So to define trigonometric ratios, you need to be working with triangles with 90-degree sine, with the 90-degree sine. Moving forward, the side opposite your right angle is called the hypotenuse. Your side opposite the angle that you are working with, for now we are working with theta. The side opposite the angle we are working with is called opposite. And the side below the angle that you are working with is called adjacent. So when defining trigonometric ratios, we're going to need these three sides, and your triangle is supposed to be a right-angled triangle with 90 degrees. We define three trigonometric ratios: sine, cosine, and tangent. These are the full names, but we're going to be using short names to describe them. For sine, we use sine. For cosine, we use cos. For tangent, we use tan. Now, we are focusing on the angle theta. And to define sine, we use opposite over hypotenuse. So looking at the angle theta, sine is opposite over hypotenuse. Also, looking at the angle theta, cos is adjacent over hypotenuse, and tan theta is equals to opposite over adjacent, which is opposite over adjacent. So always when you define trigonometric ratios, you will be focusing on a specific angle. So now we are focusing on theta, and when you are focusing on theta, the side that is opposite theta is called opposite, the side under theta is adjacent, and the side that is opposite your right angle is always hypotenuse. And this is how you define your trigonometric ratios. We have defined trigonometric ratios working with theta, working with the angle theta. We were focusing on the angle theta. Now, working with the same right-angled triangle, let's suppose now we are focusing on another angle called alpha. Now, since our focus is on the angle called alpha, always the side that is opposite the angle that you are working with is called opposite. So this is our new opposite. And the side that is below the angle that you are working with is called adjacent. So this is our new adjacent. Your hypotenuse is always opposite your 90-degree angle, your right angle, and it never changes. It doesn't matter which angle you are working with. So now, focusing on alpha, sine theta, sine alpha. Sine alpha is opposite over hypotenuse. Here, opposite over hypotenuse. Cos alpha is equals to adjacent over hypotenuse. Here is your new adjacent over hypotenuse. Tan alpha is opposite over adjacent. So tan of this angle alpha is equals to opposite over adjacent. So when you are defining trigonometric ratios, you focus on the angle that you are working with. If I'm working with theta, my opposite is this one. If I'm working with alpha, my opposite is this one. Same as the adjacent. If I'm focusing on theta, my adjacent is this one, just below my angle. If I'm focusing on alpha, my adjacent is the side just below the angle, which is this one. And your hypotenuse, it remains the same. It never changes. So when you're defining your trigonometric ratio, you must look at the angle that you are focusing on, and then you define your trigonometric ratios. Now let's define trigonometric ratios using actual numbers and angles. So first, what is sine theta? What is sine 60 degrees? We know that sine of an angle is opposite over hypotenuse. So you go to your angle 60 degrees and look where is opposite and where is the hypotenuse. Working with 60 degrees, your opposite side is opposite the angle. So your sine 60 degrees is opposite over hypotenuse. So it's root 3 over 2. That's for 60 degrees. But now, what is sine 30 degrees? So now we are working with the angle 30 degrees. You go to your 30 degrees angle. Now, what is your opposite? Opposite is always opposite your angle. So your opposite now is 1 and your hypotenuse does not change. It always remains the same. So sine 30 degrees is opposite over hypotenuse, which is 1 over 2. So the rule remains the same. Sine of an angle is opposite over hypotenuse. What changes is which angle you are working with. When I'm working with 60 degrees, my opposite is root 3. But when I'm working with 30 degrees, my opposite is 1. So that's why your sine 60 and your sine 30 will give me different solutions, but with the same rule. Now let's continue with cos. What is cos 60 degrees? Cos of an angle is adjacent over hypotenuse. I go to my 60 degrees. Adjacent is always below your angle. So it's adjacent over hypotenuse, which is 1 over 2. Cos 30 degrees. I go to 30 degrees. Adjacent is always below your angle. So my adjacent is root 3. So it's adjacent over hypotenuse. So root 3 over 2. Then now, working with what is tan 60. Tan of an angle is opposite over adjacent. So what is tan 60? I go to 60 degrees. What is opposite? Your opposite side is always opposite your angle. So this is the side that is opposite my angle. So opposite over adjacent is opposite over adjacent for 60 degrees. So root 3 over 1. 10, 30 degrees. I go to 30 degrees. What? The opposite side is always opposite my angle. So this is my new opposite when I'm working with 60 degrees. And your adjacent is always below your angle. So opposite over adjacent. It's 1 over root 3. So the rule does not change for sine, cos, and tan. What changes is the angle that you are focusing on. Last but not least, I'll conclude this lecture with reciprocal functions. Each of the 3 trigonometric functions has a reciprocal. The reciprocal, cosecant, secant, and cotangent are defined as follows. Okay, these are the full names. To define them, we use short notation names. So the cosec of an angle, theta, is equals to 1 over sine theta. The sec of an angle, theta, is equals to 1 over cos. And cot of an angle, theta, is equals to 1 over tan. So reciprocal functions is 1 over your common trigonometric ratios. So for cosec, 1 over sine, 1 over cos, is 1 over tan. So it's 1 over your trigonometric ratio that we are used to. Okay, our next lecture will be doing special angles, solving trigonometric equations, and finding the angle and the sides. Thank you very much for watching. See you next time.